So the HSD is going to be the post-hoc test. It's the same one that we learned for the independent ANOVA. The only thing that changes is that in the numerator, it's MS error instead of MS within. And a slight change to finding Q. In Q, you need the alpha level, the K value, and DF error term. Unfortunately, the table only goes as low as 5, so I used DF error of 5 to find this value since it doesn't go that low. Here I've finished out the post-hoc. You have an HSD of 1.41 when you multiply out all the components of the equation. And what this means is you will have a significant difference if you find differences between means that exceed that value. So I've listed the 3 means here, so the mean for 0 hour, 1 hour, and 4 hours. And if you take the difference between 0 and 1 hours, it's only 0.67, so this is not significant. If you take the difference between 1 hour and 4 hours, you get a difference of 3, which does beat that, so I've starred that. If you look at the difference between 0 and 4 hours, you get 3.67, so that's significant. So then I've written a sentence over here that 4 hours is significantly different from both 0 and 1 hours. 0 and 1 hour don't differ. So that's what you're looking for as the final conclusion of the post hoc. So we get an eta squared of 0.95 in this case. And what that means, it's very similar to R squared. 95% of the variation in the scores is due to practice. Right? There's another a slightly different formula for eta squared. Basically what you're doing is removing the variation to participants in the denominator to make it different than the independent. But the outcome is the same. Here I'm going to graph the mean data. So you're not graphing all the scores, but just the mean data. And so on the x-axis goes the independent variable when you're plotting these. And so in this case, it's practice in hours. And even though we only used 0, 1, and 4, you have to make a scale that is appropriate for that. And then for scores, they range from 3 to 7, so I'm going by 2, 4, 6, and 8. Because practice is on a ratio scale, if you have 4 hours of practice, you've done twice as many as 2, and there's a real 0, no practice. We can make a line graph to show the effect. So at 0, you have 3.33, so make about dot there. At 1 hour practice, you have 4. And then at 4 hours practice, you have 7. And so you can see that this upward trend with practice. And that's your graph. If you had nominal data, you would use a bar graph and the bars would not touch. So if you had flavor ratings, for example, with cereal brands or something like that, that would be on a bar graph.